Hi everybody, good evening. Welcome to our session on statistical tests / inferential tests. Tricky session tonight. We've got Anne and Anna with us, so you're in for a treat with these two going into this tricky topic, and hopefully we'll answer a lot of your questions as well. We'll go through the session, nice pacey one. It's interactive, remember, so put your questions and your answers in the chat, and if you stick around at the end, Anne and Anna will endeavour to answer some of your stat questions as well. And we'll also be mentioning things about Grade Booster, which is our student events that are coming up in a couple of weeks. And we'll talk about our Instagram page as well. So we'll get started. Who's kicking us off tonight?
It's me, I think.
Okay, Anne, when you're ready.
Okay, so everybody's favourite tonight. So we're going to be thinking about statistical tests. One thing that you might be required to do is to decide which is the correct test to use and then justify why that's the correct test to use. You need to find yourself some way of remembering this. We've got one kind of little mnemonic on the screen there. The Simon Cowell Once More Singers Receiving Unanimous Praise. But you might have one of your own, and that's absolutely fine, but just something to help you remember it. Always, when you're deciding which test to use, there's 3 questions you need to ask to get yourself to the right place in this table. So firstly, is it a test of difference? Is it a test of an associational correlation? Because that takes you to different columns. Then you need to think about the level of data. Is the level of data nominal? Is it just counting up the numbers in categories? Is it ordinal data at least? Or is it interval data? That then again takes you to different tests there. And then the final thing to think about is if it's a test of difference, what is the experimental design? So is it a related design? By related design, that means is it matched pairs design or is it repeated measures where one score is somehow related to another score? Or is it an unrelated design? So that would be if it was independent groups, because again, that's going to take you to a different point in that table. So for example, if you were doing a study that was looking at a difference between 2 things, the data was ordinal level data, or at least ordinal level data, and you got independent subjects design, then the correct test to use there would be the Mann-Whitney. If it was, again, if it was looking for a relationship or a correlation, and you had 2 sets of interval data, where there is a kind of underlying scale with equal points, then you will be looking at the Pearson's R test. So just make sure that you have some kind of table and some type of mnemonic. So I'll just throw you one quick question and see if you can get this. So you've got a study, you're looking for a difference, your data is interval, and you've got an unrelated design, you've got independent measures. So what test are you going to use? Just very quickly before I pass over. And nobody's replying. Okay, well done. We got to Sadie straight in there, unrelated to test. Okay, well done, that's great. Okay, so I'm going to pass over to Anna now. There's lots of other correct answers coming in there. It's easy when the table's on the screen.
Okay, folks. Right, so we're going to kind of jump in now and just have a little bit of a play with the sign test. Related to what Anne's just asked you to do there, I'm going to ask you to do the same thing. Can you just put in the text there the 3 reasons you would use the sign test, please? We'll see who's going to be first. I've spotted a couple of my students on there, so hopefully them. Okay, so I want 3 reasons. I can see Mary's got one of them right there with nominal data. I want a little bit more. Excellent. Right, we're coming in now. Okay, so we've got the general idea there. Well done. So we'll just run through the 3 reasons we'd use a sign test. So we've got an unrelated experimental design. Which should be related. So we're looking at a repeated measures design. We've got a difference, looking for a difference in the results, and then we've got nominal data being gathered. So well done. So just like Anne said there, that's your first bit of thing that you've got to think about in the exam is, do I know the justification for using 3 tests, and have I practiced enough stems to be able to pick out the reasons for using these different tests? Right, so moving on then. We know why to use a sign test. We're going to work through an example now with you. So we've got an experiment here on the screen. So we've got some participants learning a word list in silence, and a similar word list later with loud music playing. So we've got the difference here between silence and loud noise. We've got repeated measures design. Here's the hypothesis. So participants' recall of word lists will be greater in the silent environment compared to when loud music is playing. So that's a directional one-tailed hypothesis. We're probably going to need to refer to that later on. Let's then have a look at how we would actually carry out the sign test. Just a reminder, carrying out the sign test is something you can and most likely will be asked to do in the exam. So we're just going to have a look at some data now. Right, so here we can see, so we've got our 10 different participants for this study. We've got the silent, how many words record, and noisy, how many words record. Now, what we need to do essentially is work out the difference between those 2 scores. Really, we're only interested in the sign, but we'll just go through and work out the difference between each. So all I'm looking at is 11 minus 9, what the difference would be. So we'll just put those differences on the screen now. There we go. So 11 minus 9 is obviously 2. Now, where it says sign there, that is just, is that number a positive or negative number? And if you look down the list, most of those are positive numbers. You can see there, participant number 5 scored 10 in both conditions, and we've assigned that an equals value. Now, that's very, very important with the sign test, because anything where it is an equals value, we actually omit that from n. So although there were 10 participants in the original study, the n that we're going to use is actually 9. Now, when we're looking to go through and find out what S is, S, remember, is the calculated value. All we're going to do is look at the less frequent sign. And if I go down that list there, I can see there is only 1 negative sign there. Therefore, my S value is 1. So my calculated value is 1. Let's go through and look at the next stage then of the sign test. Okay, now you might recognise this, hopefully you do. This is a table of critical values. So when I am assessing whether or not a result that I've got is significant, I will be comparing my calculated value, that's my test result, to the critical values. You don't have to learn these tables, don't worry, they're given to you in the exam. So in the previous example, you can see I'm in the column of n equals 9. And lots of students will make an error at this point and they'll go down to 10 because they think that n was 10 because they forgot to omit the equals value. Now, let's remind ourselves, we haven't given you the level of significance for this test. In psychological research, we usually use the 0.05 level of significance, or the 5% one. We'll talk a little bit about why that is later on. So if I'm in level of significance for one-tailed tests, remember it was a directional hypothesis, and I work down, then I'm going to find the critical value there, and the critical value is 1. Now, just to point out something on that table, you've probably noticed at the bottom, it says calculated value of S must be equal to or less than the critical value of S in order to be significant. That little rule at the bottom of the table, most likely you'll be given that rule by AQA on your table of critical values. In case you're not, you might have heard of the rule of greater. It's dead simple. If the test name itself has a letter R in it, for example, chi-squared, the rule would be the calculated value must be equal to or more than. Any test that doesn't have the letter R in, like the sign test, the rule is it has to be equal to or less than. Like I say, it's most likely you will be given that under your table though. Right, let's just have a look then at what we're going to do with this. Okay, so Anne, do you want to take over?
Okay, so now we're into interpreting results, because it's all right knowing that, but what does it actually mean? So because we've said that the calculated value of S must be equal to or lower than the critical value to be significant. And yes, as 1 is equal to 1, then we can conclude that our result is significant. But then what does that allow us to do? if we've got a significant result, what are we able to then do? Who knows the answer to that? What's the there for in the study? What are we trying to do when we do a statistical test? We're trying to accept something, aren't we, or reject something? Before you generalize your findings, what have you got? What do you do? You have to either accept. There. Yep, brilliant. JT Galaxy, very clear. Crystal said hypothesis, but JT Galaxy's gone a bit further. We can accept the alternate hypothesis and reject the null hypothesis. And then you would then go further, and then you would link it and go and state what the hypothesis actually is, what it is that you. So we can accept that participants' recall of word lists will be greater in a silent environment compared to when loud music is played. So, and Jay said we have kind of established a cause there, haven't we? And then on things like your sample and so on. Okay, so well done, because I think some of these things are the real tricky stuff, in A-level stats. So you're doing really well. Okay, so another question then. What does the term probability refer to in psychology? When we're talking about probability, what are we talking about? Well done, Mariam. Straight in there. Probability refers to the chance of something being likely. The likelihood. The likelihood of what, though, in a psychology experiment? Can we just take that a little bit further? Yeah, that's the general one, that it refers to the idea something is likely or going to happen. Yeah, so, it's probably 100% likely that, in the morning, I'm going to say the sun's going to come up, but we don't actually see it, but you know what I mean. Okay, well done, JT Galaxy. It's the chance of something happening due to chance rather than an actual result. Yeah, rather than it being a true result. So, so we said probability tells us how likely it is that something will happen. And then I was kind of tease out a little bit more. A probability of 100% means that something will take place. 0 means it won't take place. And it helps us to determine whether the research findings are a result of just chance, they're just a fluke, or they're just due to errors in the research. So we also use the term significance level as well. We've got probability the IV will affect the DV rather than it being due to chance. But when we talk about things like 5% level, that means the chance level. Okay, so if we go to the next slide. So I'm just kind of almost giving the answers away here. Who can tell me what that means? What does that little p with that little arrow going that way, 0.05, how would you write that in words? Yeah, I suppose literally it does, Olivia. Probability less than 0.05. But yeah, it's and you can take it the other way, because it means that there's a 5% chance that the results, a probability that the results are due to chance, but then there's a 95% chance that they're actually significant. So both of those percentages are correct there, aren't they? I suppose there's a greater than 95% chance, I suppose, if there's a less than 5% chance that they're due to chance, probability that they're due to chance. I want to use the word chance too much in the same sentence. So P is the abbreviation for the probability of the results being due to chance. The arrow going that way means less than. If it was the other way around, it'd be more than. And 0.05, the other way of expressing that is 5%. And again, that's something that, the possibility is that they could ask you what that means. Okay, so if we have a look at the next slide, I think I'm going over back to Anna now.
Thanks, Anne. Okay, so we're on everybody's favourite now. So we're on to type 1 and type 2 errors. So just remember, as well as having to select the correct statistical test, potentially calculating the sign test, carrying out the kind of looking at the table of critical values for any test and interpreting significance, we've got questions on type 1 and type 2 errors. Now, I would say that, I'm sure Anna and Laura would agree with, these are kind of discriminator questions. So these are the questions you need to be getting right really at the kind of like top end, if you like. So type 1 and type 2 errors are all about how we set our significance levels and whether or not from that we decide to accept or reject our hypothesis. So I'm going to give you a really hopefully straightforward task just to start off with and just ask you, I can see Mariam on the chat's already straight in there. Well done, Mariam. Tell me what they are. What is a type 1 error in psychology and what is a type 2 error? And if somebody's already given your definition, try and come up with another way of expressing it, perhaps. So something else you know about those two errors. I see lots of the same type of question. Right, let's keep going just a little bit. So type 1 error, type 2 error. Think about when they occur as well. Interesting answer there from Tops. Good answer there from Sky. Okay, it's something I'm looking for. I haven't quite seen it yet. We'll see. Yeah, okay, we're kind of we're certainly getting the general idea. So let's just take a little bit of run through just to clarify your understanding then of type 1 and type 2 errors. Yes, we're definitely getting the right idea there. Right, type 1 error, we can actually say a few things here. So what is it? So it occurs when we accept our results as significant and we accept our experimental hypothesis. However, it might be the case that the results are due to chance. So we reject our null hypothesis when it could have been accepted. Now, what I was kind of looking out for, Sky's kind of got it there, is when these might occur. So if we look at a type 1 error, we might have it when the level of significance that we're using is too lenient. And what I'm saying there is it's how much chance have I allowed into my results. At the 5% level, I've allowed 5% chance. At the 10% level, 0.10, I've allowed 10% chance. So I'm more likely to get a type 1 error if I allow more chance into my results. So type 1 error, yeah, it's often referred to as a false positive result. Let's take a look at type 2. Right, so type 2 error is basically the opposite. We don't accept our results as being significant and we reject the hypothesis when it should not be. So we accept our null hypothesis despite the probability of maybe there actually was something in our results. And whereas a type 1 error is a significant level that's too lenient, for a type 2 error, it's because we're being a little bit too strict. And just think about this. We always say the most commonly used level of significance in psychology is 5%, right? And that's pretty standard for research. But there's going to be times when I have to be really, really strict. So I can't allow much chance into my results. I've got to be really, really certain of my results. I'm thinking about drug treatment, for example, for clinical trials. I'm going to have to go much more strict on my level of significance. And when I do that, I potentially miss an important result and say that it wasn't a result when it was. So type 2 error, you got it right, often referred to there as your false negative. Right? If we just move forward a little bit and we'll talk about this. Now, if we think about, if we make our significance level strict, we can reduce the chance of a type 1 error. But if we increase it too much, we get the chance of making a type 2 error. Let's then think about, why do we use the 5% level? So this is a real kind of out there question in terms of your knowledge of statistics. So your question is, let's see who can get the right answer. Why do we prefer the 0.05 level in psychology? When you're ready, pop
They did
some
ask
answers
this
in
a
chat.
few years ago, didn't they?
They did, Anne, didn't they? I was just thinking
Yeah.
that. I'm sure this has
And
been a
really
question.
young
You're right.
students as well.
Yeah, it was a definitely kind of the smaller proportion of students getting this one right. Natasha's got a good answer to start with. Okay, throw a few more answers in there. Okay, Marion says it gives appropriate leeway. You might have to give a bit more on that answer, I think, Mariam. Okay, Jay says it creates a balance between those two errors. Okay. Right, we're generally getting the right idea here. Let's just pop the answer on screen here in terms of why we prefer that. Yeah, it strikes a balance, doesn't it? So it strikes the balance between being too lenient and too strict, so making a type 1 and type 2 error. But it also leaves us a little bit of reasonable room for error. There's always going to be an element of chance that we need to allow into our results, because let's face it, we're working with human beings in psychological research. Okay, right, moving on. Anne, I think you're going to move on to some MCQs. Are we there?
Yeah, we've got some multiple choice ones here. So let's have a look at the first question. So let's see the sign. This is going back to what Anna said before. The sign test should, or what you said before actually. Which of these is correct? The sign test should be used with which of these?
There's going to be a bit of a
Just a
conformity
letter.
activity in these.
Yeah, we should say 1, 2, 3, go, and everybody has to put it up. And they did all come up together, to be fair, didn't they? I didn't. They all came up at the same time. Yes. Okay, so yes, so the correct answer is B. Nominal data, related design, a test of difference. Okay, fantastic. Let's go to the next question. Okay, so the inferential tests, this is a bit trickier. The inferential tests that are used at the interval level, where you've got interval level data, fixed scale, equal points between each point on the scale, fixed intervals. Which tests? A, B, C, or D? I'll tell you what, you're on fire, you lot tonight, because this is the trickiest area. Did you say some of them are your students, Anna?
There are, yes, Anne.
Yes. We can trust them to be well taught, can't we? Okay, so question 3, that is absolutely spot on. Unrelated to related and Pearson's is spot on there. Okay, so if we move to the third question. Okay, so a type 1 error is when? We've only just doing this, so you should remember it.
You can see this one's harder because it's slower on the response, aren't you?
Yeah, and
it's
it's
good
just a different way round. No, it is. Yeah. It's important, isn't it?
Who's going to be first?
Yeah, and then they all popped up. Freya was just in there slightly, but 3 came up together, really. I think there's just a little bit of a lag on the comments as well. Almost there with B. It's just the last bit that isn't right. It's null being wrongly rejected. Okay, so we had a bit more of a mixture there, again reflecting that this is the toughest area. I still remember my A-level in psychology many years ago, and I remember having a question about type 1 and type 2 errors, and I didn't have a flipping clue. I did by the time I did my degree then, and I do now. Okay, that's still have a bit nightmares about them. Okay, then, so I'm going to pass back to Anna now.
Okay, so we've got a little couple of questions just for you to trial as well, just related to using these tables of critical values. So not a lot of information on here, but enough for you to access this question. So we've got a piece of stress research. Here's our hypothesis. There will be a positive correlation between the number of days participants have been using biofeedback to treat stress and reduction in heart rate. You don't need to know what biofeedback is in this question, don't worry. So I've given you some of the information on there. So we've got, it's a one-tailed test. How do I know that? And it's because in the hypothesis there, it does say there will be a positive correlation. Right, we're going to use Pearson's R for this. Now, if you look on the table, and I'm not telling you which one it is, you will hopefully be able to identify the correct critical value. So you've got the information you need on there. N is 10. The level of significance is 0.05. Should be able to select the right one. You've got a couple highlighted there, but for a reason. You've got to make sure you get in the right column. So all I want to know is the result significant? I'll just wait for a few more answers just to pop in the chat, and then we'll just run through the correct response to that question. Oh, Natasha Louise, you're going a bit further on that. That's good. So you started to explain why it is significant there. So that's great, because that's what we need to take a look at. Excellent. Oh, talking about the hypothesis there and what we do. Excellent. Right. Do you want to slip on to the next slide and we'll just have a look there at that result in terms of what we're actually going to say about it. So we've got, now this is how I'm going to write it up. So I've got when n equals 10, so number of participants, the level of significance is 0.05, one-tailed hypothesis, the critical value is 0.947. Now, there's 2 highlighted there because we're just trying to trip you up, really. You might have been in the wrong column. So we've got a result that's significant and we're going to accept our experimental hypothesis. Okay, that's the first one. Let's have a look at another one. Right, here we've got a bit of gender research. Again, limited information, but enough for you to do it. So we've just got a hypothesis. There will be a difference. And hopefully you see that and you're like, oh, that's non-directional. That's a two-tailed. We haven't told you how many participants are in the study, but let's say there were 22. And I've said that DF is n minus 2. So that's going to bring us down to 20 on that table. So again, is the result significant? And how do you know? So give me a little bit more then. It is or isn't significant this time. So what's your calculated value? What's your critical value? Rule of greatest there's on the bottom of that table. So significant or not? Who's going to be first then? Oh, here we go. Okay, so slightly different in opinion here. Okay, so let's just take a look at the answer that we've got. Okay, so we've got the calculated value of 0.116 is less than the critical value, therefore the results are not significant. Excellent. Right, so you've got the kind of general idea there. The advice I'd give you on these stats questions when using the table, it's good to see you taking your time, is to do that. There's so many ways you can trip up. Check, do you know what kind of hypothesis it is? Just remember, if it's a directional hypothesis, it's one-tailed, non-directional is two-tailed. Check you're in the right column for the level of probability. Check you've got N right or DF, especially with the sign test. Remember that rule. Any equals values, you must omit them from N. Okay, over to you, Anne, just for the last bit.
So it's really answer quickly on this. You've got 10 seconds to answer the question that you see on the screen. So let's have a look at the first one. Okay, so when may we want to use a probability level of 0.01? I don't know, I think you need... that was very quick. It came up before they'd even had a chance to write it in. There is a bit of a lag. They have got the answer. There's a word on the chat. Yeah. I think 10 seconds a bit fast, isn't it? But yeah, you've talked about drug trials, things where it's really, really important. I think sometimes in some replication studies they use 0.01 as well, where they're really trying to check the reliability of something. Okay, brilliant. Okay, we'll try this on the next one. But as I say, I know the answer will come on before yours pops up. Okay, quickly then, difference between type 1 and type 2 error. I don't think 10 seconds is enough to type it.
Will anyone make it in time?
We've got the countdown now.
Yeah, you could say that, Natasha Louise. Cool.
Yeah, that's the quickest way to do it, I think. That's how I have to do it. Yeah, you got this kind of too lenient versus too stringent as well. Yeah, so we went down that route, but I think, I had the other one as well, and Tasha's one written down as well. But type 1 occurs when the level of significance is too lenient, and type 2 occurs when it's too strict. Which one of you did say? We've got a really long answer there, which is more like you would write in an exam off JT Galaxy. That would be a really good exam answer. So well done, everybody. I'm so impressed.
I know. That was a tough session, that wasn't it? We threw a lot of hard stuff at them there.
Really? It was really the tricky bits.
And do you remember that year where one of the questions for the students to answer was to write the suitable hypothesis, and then they had to use the critical value table and remember that they wrote the hypothesis?
Oh my
That was a
goodness.
tricky year,
Yeah.
wasn't it?
Yeah.
So we've done a lot on type 1 and type 2. I think some students know which, they know the false positive, they know the false negative, etc., but maybe muddle which one is which. Have you got any tips for how to remember which at least is the type 1 one?
No. No, other than to learn it, really. Yeah.
Well, which one do you
So it's
think is the
one false
worst
positive.
mistake? Which was the worst, do you think? Making a
What, in,
type 1
in respect to type 1 and type 2?
Yeah.
Yeah, I suppose it depends what you're investigating as well, isn't it? Because even on the drug testing, you don't want to throw away, not use a drug that might have worked for quite a lot of people, do you? You know, it's really hard. I think it's a really hard decision to make, isn't it?
So we think of flashcards, rote learning, repetitive testing, practicing your
I think
questions.
it is just learning. I think the type 1 false positive, type 2 false negative, I think that's the easiest way to remember it, and then you can work it outwards from that, can't you?
It reminds me when I was younger trying to learn left and right. I just thought, well, if I can remember which one's left, I'll just by default remember which one was right. So just
I think
learn one of
Amelia's
them.
got one here. Amelie, type 1 is false positive because it seems like an odd number, which I associate with being negative. Yeah. I think you just do have to find your own little ways, really.
Yeah, you really do.
Yeah.
Fantastic session. Just a reminder to everyone, we are back next week, but on Monday instead, 17th, Anna's birthday. We'll be here and we will be doing approaches, is it? Yeah, we're on approaches.
Yeah.
So just make sure that if you come in next week, that it's Monday, not the Tuesday, just for that week only. We're also
it's me next week too, yeah.
We're also gearing up. Sorry, Anna, I didn't mean to leave you out there. We're also gearing up for our grade booster events. So if you've been great, we hope to see you again. And if you've not, check them out on the tutor2u.net website. Fantastic days, aren't they, Anne? You're there at most of them, aren't you?
Yeah, no, they are. But again, we make you work very hard, but you're all more than capable.
Yeah, come and spend the day with us. We're hitting Manchester, Leeds, Gateshead, lots of dates in Newcastle. We're down in Bristol as well. We'll pop some information on our Instagram where you can also see reminders and revision stuff several times a day, and that's at tutor2u's sake. So until then, thank you to Anne, thank you to Anna, and we shall see you all next week.
Next week, yeah.
Okay, goodbye everybody. Thank you very much.
Bye.
Well done. Thank you.
Bye, yeah, very well done.